So we're going to do this problem, which is number 4 from the homework, using the formula. Oops, let me get the pencil. We want to find the slope of the tangent line using limit as x goes to a of f of x minus f of a over x minus a. So now, can you guys tell me, if we're given the point 1 comma 0, what does that tell me in the formula? Which values?
F of A.
And? A. So what does A equal?
1.
And what does f of A equal?
0.
So we can fill in these values. So now we have the limit as x goes to 1. F of x is just our original equation up here. So f of x is just going to be x minus x cubed. F of a is 0. And x minus a is now x minus 1. Okay, feel okay?
Yeah.
So now we have a limit problem that we can simplify. Whoops, that's not how you write an M. So now I have x minus x cubed on top over x minus 1 on the bottom. We're going to need to factor that numerator. If we factor out an x, I look like this. X times 1 minus x all over x minus 1. Now if I factor a little bit further, I have x times 1 plus x, 1 minus x, because that's the difference of squares. Now we saw a little bit in, it must have been section 2.3, what to do when we have this 1 minus x and this x minus 1. Because they're close, but they're not exact matches. How do we reduce this fraction? What are we going to do?
Take a negative out?
Yeah, let's take a negative out. And we can do that at the top or the bottom, but I think we're probably used to doing it on the top. So I am going to, I need to give myself a little more space. I have only a little space on the screen. I'm going to go over here. Oops. Okay, hopefully that fixed it. We'll find out later. So if we want to factor a negative out of the numerator, I'm going to pull that all the way out in front, so I'm going to have like a negative x out in front, times 1 plus x, and that's going to switch this to x minus 1. And now it reduces. And now I think this is going to answer your question before, Abby, about where the negative came from. I think it's that negative x out in front. So now we can plug in 1 for x. So now I have negative 1 times 1 plus 1, giving me the negative 2 that I was looking for. Answer. How does this problem feel? Okay, so if we do number 7 from the homework, so we have y equals, fellas. Okay, so we're going to do number 7 from the homework, which is y equals square root of x at at 1 comma 1. And because most of us did the first formula when we were doing this problem last night, we'll do that one here now. So we're going to use the limit as x goes to a of f of x minus f of a over x minus a. So now if we have the point 1 comma 1, this is going to give us a and f of a, and they're both 1. So we're going to plug in the limit as x goes to 1. F of x is the square root of x. F of a is 1 over x minus 1. So, right, so we have this limit problem, and this is a type of limit problem that we would have done back in section 2 with the square roots. We're going to multiply by the conjugate. What is the conjugate of the square root of x minus 1?
Square root of x plus 1.
The square root of x plus 1. So if we FOIL out the top, so now I still have the limit as x goes to 1. On the top, when I multiply that, that multiplies out to x minus 1. On the bottom, and remember when we were doing this, the rule of thumb was to not multiply out the bottom. Right.
Oh, you just cancel this bad, but you get one. No, your answer's still 1/2. Oh my god.
Okay, so we reduce the x minus 1s. Leaving us with 1 over root x plus 1. We can plug in 1 for x, which gives us 1/2. So what this number is, what we just found, we found the slope of the tangent line. All of this, all these formulas, they're to find slope. So we know that the slope is 1/2, and we know that a point that the graph passes through is 1, 1. So this is what we were talking about when we were doing number 3. We have a point and we have a slope. Let's use point-slope form. We're looking for the equation of the line. So we're going to use point-slope form and plug in our values. That's a really good question that I have no idea what the answer is. It's been M for a long time, and that's all I know.